Hello everybody, my name is Yasser. In this video I will explain the case study 1, which is assigned for students of software engineering economics, summer 2017. And the case study is to estimate effort using a Cocomo model. So to understand Cocomo model, you need to go to this reference and read the section that explain the model and learn how to apply it in this dataset. So first we need to go to the reference. So when we open the file, this is where is the file? Yeah, this is the file. Okay, so when you go to the file, you need to go to the page 664. Yeah, I believe, and this page has a section called the constructive cost model, which we refer as Cocomo. So this is Cocomo model. So go through this section. It will explain to you how to calculate or how to estimate effort using the model. So basically what you need is to calculate nominal development effort and multipliers of the 15 cost driver attributes. So these two values can be found in the dataset. We go now to the dataset to see. So the link, yeah, this is the link to the dataset. So this is, we need first to copy, so the data start from here. So we need to copy this data and paste it in Excel sheet, because yeah, so when we paste it, you can see that all of them are gathered in one column. So what do we need actually to separate them or put them in multiple columns? So they should be separated by comma. So in order to do that, we need to go to data, first highlight the column and go to convert from text format to columns. So when we choose this option, we go and we make sure that we select comma here. So every metric is going to be separated from the other. So this is our data set. So as we can see that we have 93 projects, but what we need to do is we need to insert one row here, because this row will have the metrics. So where we can find our metrics, or the title of our metrics, we go back to them here and we go section 7. Yeah, so this is the attribute information. We start from, so this is the first one, is unique ID, which is the project ID, and this is the project name and the category of the application. So what the application is designed for? Is it a science application? Is it simulation? Is it utility, communications? And because this dataset is the projects in this dataset are coming from NASA, there is two type of applications. There's applications designed for ground, and there is application flight application. So, and also what's the center of NASA, which center of NASA this projects come from, and what year of development. So, and the main thing here is the development mode. So we need, this is very critical here, because this is going to help us in calculating the nominal effort. Because if we go back to the document, so here's our document, we can see in uh, this table. Okay, so this table, it's show you that for every type, or for every mode. Okay, so if you want to understand the organics, semi-detached or embedded, what's the difference between them, you can read the articles, you can find information about them, but it's not our topic today, because today is just uh, I need to explain how to extract the data and how to use them in and how to calculate your effort. So we see if the type of mode or development mode is organic, then you use this formula, or if it is semi-detached, you use this formula, and so on. So the first, so we have the data set here. Actually, I have it here because in this one I already wrote the metrics. So what I need here is to uh, see okay, the development mode, and then I go and create a formula here using if statement to calculate what's the nominal effort. So in here we can write down nominal effort, and this will be equal to using if statement. Then we can if the project is semi-detached, then apply this formula. If it is organic, then apply this formula, or if it is embedded, then apply this formula. KDSI is referred to the thousands of deliver source instructions, which is the line of code. So where is the lines of code in our dataset? Is here. So it's already in kilo. So we just need to put this number, plug it as this value, KDSI. So we just plug the lines of code here, and we calculate our nominal effort. So we have the nominal effort here. So once we have it, then the next one we need to multipliers. So multipliers is all the numerical value representations of all. This is the cost or driver metrics. So this is the cost, or this metrics are the one who determine our cost. Okay, reliability, complexity, time. So let's see it in the data set. We'll go to the data set again. We can find, yeah, this is our data set. So we can see in here our driver cost metrics are reliability, data, complexity, time, storage, virtuality, turn, analysis capability, application experience, programming capability, virtual experience, language experience, and mode. I'm not sure about this one, but you can find the explanation of the metrics somewhere here. And tool and schedule. So those are the metrics that determine the what is called the driver, the cost driver. Okay, or the cost or the metrics that the multipliers of these metrics are will give us the cost if we multiply by the nominal effort. So let's go back to the our document here, and we see in this table we can see that the rating are from very low to extra high for every attribute, for all the attributes. So reliability, so this is the explanation of this. So this is like modern programming policies and the tool, and the required development schedule. So we find that it's actually the number is different. The numerical, so it's in the data set is a categorical representation, so we need to convert them to numerical representation because we need to multiply. So because we cannot multiply the categorical variable, but we should be able to multiply numerical values. So for example, in reliability, very low is equivalent to 0.75, and nominal is, all nominals here are equivalent to 1. So high is for example, reliability is 1.15 and so on. So the number is different here because here when you have when your values are low in these requirements and the reliability and the data, then this will if it is low, it will make the efforts or the estimate of the efforts low. If they are high, they will make the effort high. But here is the opposite. You know, if they are if you have lower application experience or programmer capability, then it will cause high cost. So here is the better if you have high level of personal attributes, you know, so this will drive the cost or the effort to be low. So just make sure that you convert all the categorical variables. So to do that, you need to go to here, and for every variable starting from reliability and to the schedule here, so for everyone you need to also make a if statement, and if it is h, then the numerical representation is 0.75 or whatever, and if it is neutral then it's 1, if it is low then it is this number, if it is very low then it is that number. So after you finish, so you repeat this process with every metric here until you get all metrics are have numerical equivalent values. So once you have all these, then you can calculate the multipliers, which is going to be the multiplication of all these numbers for each project, and you will have the result here. So at the end, your estimated effort will be here, and this estimated effort is going to be this cell here multiplied by this cell here, this one times this one. So and you have, and then you should have it for all projects. So then you need to analyze the estimated effort against the actual effort. So the perfect situation is when they are exact and when they have exact match. So this is the perfect situation, but this is very unlikely because you should have higher or lower values than the actual effort. So the closest of this value to this value is the better is your estimation. You need to see how many projects are overestimated. So if they are overestimated, that's mean this value is higher than this value. So if they are underestimated, then this value is greater than this value. So you need to see and analyze what's the difference between the estimate and the actual effort. How many projects are having, for example, 5%, 10% overestimated, or how many projects are having 5, 10% or more than that underestimated. So you will find some projects that are having very big gap between the estimated and the actual effort. So you need to analyze this projects carefully, and you see what drives these projects to be either over or underestimated, and you analyze all the metrics and what happened. Is there some metrics where having for example extra high, very high, So you need to evaluate that across all the projects to see where was the problem, where was the problem. So try to analyze that and figure out what caused this bad estimation. So I think this is pretty much everything you need. Um, if you have read your assignment carefully and try to understand all the requirements. So if you have any problem understanding what is required, or what if there is any of the questions are not clear or need more clarification, then you are welcome to send the questions and ask about it, and we will try to do our best to answer them. And for now, good luck, and thank you very much for listening to this video, and enjoy your course.